Hi, everybody. Okay, now we're ready for our next measurement. This will be a measurement of the driven motion of our physical pendulum, but in a condition where the drive amplitude is very small. We can adjust the drive amplitude by moving this lever arm across the pivot point, basically to make the amplitude of the motion larger or smaller. In any event, we can control the amplitude of the driving motion easily. What we expect is that if the amplitude of the driving force is very small, that the system probably will behave like a linear oscillator. Here, let's try it out. So now we're driving the system close to its resonance frequency, and you can see that the cable, the string, is actually attached to that white square, and it's hardly moving at all as the drive arm moves. So the amplitude of the drive is small. And you can see that the amplitude of the response is also small. We're going to let the system sit here and for a few minutes to settle down so that the initial transient motion associated with turning it on fades away. And then we'll come back to it. So 1 second. Okay. Now the system's been running for several minutes. I made a few other minor adjustments too. And I think we're ready to collect data. So now it's settled down into a steady state, okay? We'll go ahead and start the acquisition and let's see what it looks like. There we are. All right, this is going to run for 100 seconds. And then we can talk about what the results are. I'm going to use auto scale to make these graphs a little easier to see. There we go. And I'll just step out of the way now. Okay, now that data collection is complete. And can you see what we've got? Here we have an almost perfect sinusoidal wave. Not quite perfect. This is experiment, remember. The Fourier transform of that is a peak. It has a very narrow width now. And what's interesting is to look at the phase plot. You see what the phase plot looks like? So probably you'll see that this looks like, oops, a circle. I'm sorry, I'm going to just go back and rescale that. There we are. Okay? So, so that's something to keep in mind as we go ahead now to the next cases we're going to consider.